All right, hello everyone and welcome to our next installation of the nanoCHAT NeWBiEs series where we're joining Wes Farrell and Shirley Lynn as they are teaching inorganic for the first time weekly here. We're hearing from them. They're both at the U.S. Naval Academy in their chemistry department. So welcome everyone and welcome to Wes and Shirley. How's it going? How was this past week? How are you?
So we both gave quizzes this week on symmetry, group theory, and molecular orbital theory, which I was pretty excited about, but I think we both ended up pretty disappointed with how the students performed, specifically on their question about sketching a molecular orbital diagram. So we asked them to draw the molecular orbital diagram for beryllium dihydride, and I thought they were going to knock it out of the park because we had done water, we had done borane, we did ammonia, we did all these examples of just some first row P block metal or non-metal, and then also hydrogens. So this was very similar. So I thought they would just kind of follow that format that we had done. And the answers were just interesting. We'll leave it there.
Anytime you have students draw, it's always interesting, I've found. So.
Yes, they were very creative, I'll put it that way, but that led to a lot of incorrect answers. So I think it's really, for me at least, led to need to reflect on how it is we went about this material, and then what was missing in what we did in lecture and during our discussions that led to this outcome. So that's something I'm going to be thinking about for the next time we go through this, and also think about how we can remedy this before their upcoming exam.
Right, definitely. How about you, Shirley?
I saw a lot of similar things to Wes's section. I scaffolded the question a little bit differently. So I included a part where they had to draw the Lewis structure and name the geometry using Vesper, and then assign the point group. And then I had them come check with me, and I had another sheet of paper during the quiz with the character table and the salts. And I just gave them that, and then they could fill in the molecular orbital diagram. And I'd love to say, wow, that solved everything. But even though the students could largely do the first parts all the way up to the point group, yeah, there's still a lot of confusion about what to do with the salts and how to construct the molecular orbital diagram. And there were sort of big ideas that I thought were straightforward, like, conservation of number of orbitals. I was expecting not to have a problem with the number of electrons to put in the diagram. I didn't think they would have an issue with. So we just need to have more of a conversation when we get back to class next week. But I agree with Wes that our goal is the next exam and how to get them ready for it. We already have a question picked out for the MO. So we're sort of, no spoilers, but we're going to, we're going to test them out a little bit more on this, and we want them to feel as prepared as possible.
That's interesting. I think you all have gone more into the MO theory than I typically do in my class, but I think that approach where you're scaffolding it and building confidence in your students as they go along, even if they don't fully grasp the MO part, which hopefully, as you said, you'll be able to address before that exam. Like I said, I hate grading. Well, I guess I didn't say this, but I hate grading MO diagrams where they have to draw, because you get so many, would you say, creative answers. So one thing that I tried the last time I taught this on my exam, and hopefully this isn't spoiling your exam, I guess I should check, is Chip Notaro has a great MO LO where he gives them an MO diagram that has errors in it, and they have to find the errors. And then they have to explain and correct the errors. So it's getting at the same concepts without them having to generate that MO diagram. They still have to know everything, but it's taking it from a different approach. So I really like that as an assessment tool. And I actually recommended it to our newbie. We have somebody who's teaching inorganic for the first time this year as well. So I think she's going to use it on her exam. Or maybe she already did. I think she already did. So MO, you said you were also working on solids. How are solids going?
I was excited to jump into it because this is something I did not remember learning as an undergrad, like at all. And it really was helpful. Wes and I have a colleague in the inorganic subdiscipline, Matt Buck, who is a materials chemist, so he's a nano person. And I just having chats with him has been really helpful in how to frame it. So he likes to think about how metallic elements are and how ionic they are and how those properties then influence the sort of structures that you see in the solid state. And that's helped me sort of put a little bit more of a frame around what we're talking about. But as far as learning the structures themselves, I'm kind of right along with the students, right?
Right.
For US.
Yeah, so similar to Shirley, I haven't seen this material in quite some time since I took this course, which is an undisclosed number of years ago, but it's been
Fewer
quite a
than
while.
for me.
Yeah. So yeah, the biggest challenge I've found is that, I'm learning it and I'm, picking it up pretty easily, but then I'm having a hard time getting them to understand and be able to visualize these things. Like we draw one unit cell, but it's hard to get them to realize, there's another one right next to it. So we're talking about coordination number and stuff like that. They only seem to consider the ones that are right in there in that unit cell. And then when I ask them to like kind of expand it, things kind of fall apart.
Right.
Also going back and forth between these 2D and 3D projections. So I'd actually never seen a 2D projection. Now that I see it, I think it makes so much sense and it makes things a lot easier. But they are seeming to have a very hard time going back and forth between the 3D and the 2D projections.
Right.
And I think that also has to deal with just this inability to visualize these things in three-dimensional space, which I thought would be a little bit easier after doing point groups because they had to visualize these molecules rotating and reflecting and all that stuff. But it's been a little bit rough so far. But I did on Wednesday do the ice kit LO that Nicole, I think you put on Viper. And I'm going to go through some problems today now, kind of going back to more of a lecture format after that activity. And I'm hoping that that activity helped them with this visualization. But I don't know, I'm interested to see your thoughts on what should we keep in mind when we use this? Shirley hasn't done it yet, so it's not too late for her to say.
Well, that's good. I can give some pointers maybe. As far as the visualizing the unit cell, because that is something hard. They don't think about how do I split this? I'm like, obviously you split it in half, or whatever. I like to tell them to think about a Rubik's Cube because they've all seen a Rubik's Cube, and then envision that the unit cell that you're talking about is in the center of the cube. And then you can see all of the other unit cells all around it. I don't know if that helps, but that is something that at least it puts it in a frame of reference that they've thought about before, that it's not an isolated cube, right? That there's a larger 3D structure in terms of that. So I don't know if you could try that. I like to use a lot of models. So I have all my old model kits that I have for this because, as you were saying, I didn't cover this much in my undergrad. So I was definitely experiencing that same thing where I was learning it along with the students, and that old saying of teaching it to someone else helps you learn it definitely came true those first years. So, realizing where are the holes in students' understanding, pun intended there.
Are the holes tetrahedral or octahedral?
That's where I like this one because you can do trigonal and then you can do tetrahedral and then you can show them the octahedral, right? And it kind of puts it in perspective that all of those are not just isolated holes, but that they're all coexisting, and which ones get filled depends on size. So I think, bringing in the model definitely helps. Plus they love watching you try to juggle all of that in the front of the classroom, which is fun. The model kit LO is really kind of grew out of that. It's hard to manage in a single class. I've actually cut out the last two, like E and F, in the more recent iterations because they're really hard ones to build. And I don't think that you gain a lot from that. So that's looking at like Wurtzite and the zinc blend and then graphite and diamond. Those are just really hard to build in the model kit. But I think my favorite one, and I actually brought it, is the sodium chloride on the body diagonal. And what I really like about it is that you can see the A, B, C, A layers in it and how that gives rise to the FCC unit cell. So I love this one. This one I like keep out and keep referencing back to with my students. And I think that like the physical manipulations help them realize or tie back the content to what we're just lecturing with.
Yeah, I hadn't actually done them until the morning we did the activity. And I noticed that when I did that one, I was looking at it, I was like, oh, okay, you know, it's got the ABC, but then if you just turn it 90 degrees, you can see it's base center cubic. And it was like a light bulb went off for me. So I got really excited trying to point that out. And I don't think they were as excited.
No, but maybe in time.
Yeah.
Well, we are getting close to the time point here. We're trying to keep these nice and short. So thanks for this great conversation. Obviously, we can continue having these discussions about MO theory and how best to get students to wrap their heads around that. And then moving from kind of the isolated to the more extended with the solid structures. And we can continue this conversation on the Discord. We have the Ionic Discord, the Viper Pit. So feel free to talk about this nanoCHAT NeWBiEs edition here on there. And you can find these videos and all of the videos in the series on our YouTube channel. So thanks again for tuning in. Thanks for the conversation, Les and Shirley.
Thanks, Nicole.
Thanks, Nicole.
Take care.